In the reactions, 5 moles of nitrogen gas and 8 moles of hydrogen gas is introduced into a sealed 5 decimeter cubed container. The reaction reaches equilibrium at 400 Kelvin. At equilibrium, it is found that 2 moles of ammonium gas is present in the container. Good day, guys. I hope you're all doing so well. Welcome to our today's lesson, wherein you're going to deal with calculating the value of Kc. Now, this is a chemistry class, physical sciences, paper 2, grade 12. Chemical equilibrium is our topic. So now, let us simplify it very fast. We have 5 moles of nitrogen gas and 8 moles of hydrogen gas. These two gases are introduced into a sealed, that means a closed 5 decimeter cubed container. Now we have a volume Now we have a volume that equates to 5 decimeter cubed. It's our volume. That means these two gases are sealed into a container. That means initially we had 5 moles of nitrogen gas and 8 moles of hydrogen gas. That's very important. Now, the reaction reaches equilibrium. That means the reaction reaches the end. Which means the reaction takes place and it reaches the end at 400 Kelvin. This is our temperature, 400 Kelvin. At equilibrium, after the reaction has ended, it is found that 2 moles of ammonium is present in the container. It means after nitrogen gas and hydrogen gas reacted, we found, or they produced ammonium, of which its number of moles equals to 2 after the reaction. So now, here's our reaction. Here's our balanced reverse reaction. Nitrogen gas plus ratio of hydrogen gas is 3. It forms a ratio of 2 for our ammonium. So now, you need, before you can, here's our table, by the way, guys, and the question says you must find or calculate the value of Kc. So Kc, one of the simplest methods to calculate Kc, you need to know the number of moles, the number of moles of all these 3 gases at the end of the reaction. So you need to know the number of moles at equilibrium, basically, for you to be able to find our concentration. That means our aim here is to find concentration. And for us to find our concentration, concentration is equals to N over V. For us to reach Kc value, we need to know our concentration of this reaction at the end or at equilibrium. And for us to, in this case, we already have our volume, which is 5 decimeter cubed, but we don't have the number of moles of all these gases at equilibrium after the reaction. We only have one known value of our number of moles, which is for ammonia. We only have the number of moles at equilibrium of ammonia. We need to find number of moles of nitrogen gas and hydrogen gas at equilibrium for us to find the concentration and ultimately find the value of Kc. That's our aim. Now, how do you fill in this table? It's very important to understand this table before you can write your examination or a test that has to do with chemical equilibrium or that has to do with finding the value of Kc. Now, let me just assist you in terms of how to draw the diagram and how to place your values and stuff. You need to understand and memorize this diagram. So now, I have drawn this diagram like this. We've got 3 blocks here. 1, 2, 3. This, you leave out this one. I'll tell you. The first block, you come back to your reaction, your balanced equation. We've got nitrogen gas. You write your nitrogen gas here. Nitrogen gas is these are our reactants, and hydrogen gas. 3 hydrogen gas. And here on the last block is our product, which is our ammonium. 2 ammonium. Now, guys, so here is our gases. Is a gas. Is our gas. Now, on the first block, you write the ratio. On our second block, you write the initial mole. I'll come back now. Then on our third block, you write the change in mole. On our fourth block, you write the mole at equilibrium. Okay, you can just write equilibrium mole. Then on our last block, we write our, okay, then here we're going to find our concentration here. Concentration in, yes, here's our concentration. And the concentration is C is equal to N over V. So you can literally create another block. It's not a problem. It's your choice, literally, guys. Yes. Let us fill in the form. Now we have got our ratios. The ratios, if you find ratios you found in front of our gases or in front of our elements. So now you know that nitrogen gas, our first element is nitrogen gas. It has got nothing in front of it. There's no number here, but it's 1. Mathematically speaking, it's 1 here. Then hydrogen gas has got 3. This 3 stands for our ratio for hydrogen gas. This 3 stands for our ratio. Then ammonium, this 2 stands for its ratio. That means you're going to write those numbers here. So we've got 1, 3, 2. Now, the initial mole, remember, they said that hydrogen gas and hydrogen gas and nitrogen gas are in a sealed 5 decimeter cubed container. That means initially they were sealed here, and we've got 5 and 8. That means in a sealed container, we've got 5 and 8. For nitrogen is 5 moles, and for hydrogen is 8 moles of. Yeah, those are our initial moles. Because the reaction has not even taken place. So you're going to write those values there. We've got 5 for nitrogen and we've got 8 for hydrogen. Now, they said nothing about our ammonium. Initially, when all these 2 gases are inside a container, they talked nothing about our product or our ammonia. Why? Because ammonium, it is not yet formed. The reaction takes place between nitrogen and hydrogen gas, and when these 2 takes place, they're going to form ammonium. Hence, ammonium initially it has got no number of moles. You write 0 here. They like to do this in the examination. Now here's the trick, guys. So now you write 0 for your initial mole and get sharp. Now changing mole, you come to the third block. Changing mole. Changing mole is during the reaction. What is the number of moles of all these 3 elements or gases during the reaction? Now, we talked nothing about what happened during the reaction. You just leave it like that. You can write X, or you can just leave this block like this for now. Let's leave this block and write what you know from the statement. Now, at equilibrium mole, you're coming back here. Equilibrium mole. After the reaction has taken place, at equilibrium, it is found that 2 moles of ammonium is present in the container. After the reaction or at equilibrium, 2 moles of ammonium is present in the container. That means equilibrium mole here. Here's our ammonium. We write 2. Now, we need to find a change in mole. We need to find change in mole. How do you find change in mole, guys? This is so simple, ne? Now, for us to find change in mole, we need to understand that during the process, ne? So guys, for us to find change in mole, we need to check which side has got more numbers and product side, and I've got 2, 0, and 2. And for us to find change in mole, some teachers say that you must minus the equilibrium mole from the initial mole. If you've got the equilibrium mole, just minus the equilibrium mole from initial mole. That means 2 minus 0 is 2. Then you've got your change in mole for our ammonium. Then for us to find change in mole for hydrogen gas and nitrogen gas, it's so simple. we're gonna use our ratios. We're gonna use our ratios. How? So now we've got the ratio of nitrogen. Changing mole of hydrogen gas. Changing hydrogen gas is to our product. Ammonium 2NH3. So the ratio is 1 is to 2. Changing mole for our nitrogen gas. Therefore, X monana. X monana is to 2. Then you're going to cross multiply. When I say 2 times X is 2X is equals to 2 times 1 is 2. Therefore, you divide both sides by 2 to find X. 2 divided by 2 is 1. Therefore, changing mole for nitrogen gas is 1. And guys, changing mole for hydrogen gas, you're gonna say, what is the ratio of hydrogen gas? Is 3 is 2. What is the ratio of our product? Is 2. Therefore, about changing mole for hydrogen gas, you just write X on our left is to 2. Then we're gonna cross multiply. 3 times 2 is 6. Here we cross multiply. Or 3 times 2 is 6. 2 times X is 2X. Then you divide both sides by 2. You divide both sides by 2. Therefore, X here gonna give guy 6 divided by 2 is 3. Therefore, we're gonna write 3 here. That is how. That's so simple. Now, guys, it's so simple. Then now, how are we gonna find the equilibrium mole? It's so simple. Equilibrium mole. How do you find it? You're going to say initial mole minus change in mole. That means 5 minus 1 is our 4. 8 minus 3 is our 5. That's how you find the equilibrium mole of those elements. That's how we found the equilibrium mole. So you just say 5 minus 1, 8 minus 3, they give you our equilibrium mole. Therefore, what concentration of each element. So therefore, concentration for nitrogen gas, let me just do this, concentration. So we're going to say C is equal to N over V. Now, let me just substitute immediately. Number of moles at equilibrium is 4. 4 divided by 5. Therefore, C is equal to 4 divided by 5. Keep going, guys. 4 divided by 5. You can literally press it on your calculator. Then you come to the second part. Number of moles divided by volume. 5 divided by 5. 5 divided by 5. Then C only 1. Here, you're going to say number of moles is 2. 2 divided by 5. Then C only keep guy 2 divided by 5 is 0.4 leona. 0.4. And this is the values of our concentrations. Then therefore, since now you've got our concentration, you can use it to find them. So you have found the value of our concentration. Therefore, Kc is equals to the product concentration of the product squared divided by the concentration of our reactant squared. So now the product, what is our product? Concentration of NH3 squared divided by concentration of hydrogen gas H2 multiplied by concentration of nitrogen gas. This is equal to, now you take this, concentration is 0.4. You get square demo. Square demo now. Square of fair. So 0.4 squared divided by concentration of hydrogen gas is 1 squared multiplied by concentration of nitrogen gas is 0.8 squared. Therefore, the Kc value there 0.25. This is how you find the value of Kc. I'm done, guys.